Hello friends, welcome to the channel. In this video, we are going to discuss the connections between t-test, confidence interval, and regression coefficient. So before starting this video, I would advise you to please watch my previous video where I constructed the data for temperature and sales and used linear regression to fit the model. The link is available in the description box and on the I button above reflected on the screen. This will help you understand the independent variable, which is temperature, and dependent variable, which is ice cream sales, and how we can use the linear regression model. So coming back here, let us create simple linear regression model by creating data, which is my data in this case, through data frame function, and creating variables temperature and sales. And now I want to run the regression and look at the summary. So here we can see the coefficients for intercept and temperature. But if you want to see only the coefficients, we can use the syntax COEF that represents coefficients for the regression we just conducted. So these are the coefficients for intercept and temperature. Our LM equation where Y is our scale, X is the temperature, A is the intercept, and V is the slope of temperature. And we can put the value of these coefficients in this equation and construct the model. Our task is to calculate confidence interval for the slope of temperature when the confidence level is 95%. For more information on confidence interval, you may please see the related video as mentioned in the description box or reflect in the I button above. So first, we'll calculate the confidence interval manually through t-distribution table to understand the fundamentals behind it. And then we'll see how can we do it with the help of syntax in RStudio. So for calculating it manually, we require two things, df, just degrees of freedom, and the critical t-value. The degrees of freedom are the number of values that are free to vary. When we perform t-test for regression slope, our degrees of freedom is n minus 2. N is the number of observations. For example, if we print my data, which we have just created through data frame function, we can see that there are 10 observations. So our N is equal to 10. So 10 minus 2 is equal to 8. So our degrees of freedom in this case is 8. The second thing which we require is to know the critical T values. We know that the confidence level is 95% in this case. Our task is to calculate confidence interval when the confidence level is 95%. When confidence level is 95%, we can calculate the significance level, which is 1 minus significance level is equal to confidence level. So we call significance level as alpha. When alpha is 5%, the confidence level will be 95%. Or the other way around. When confidence level is 90%, alpha would be 10%. Or when the confidence level is 99%, alpha would be 1% respectively. We know that our alpha is equal to 5% based on the confidence level. And this is a two-tailed test. So we can calculate the critical t values lower and upper in the two-tailed t distribution table at alpha 5% and degree of freedom 8. So let me just show you the t table to look at the critical t values. So here is the t table. We know that the degree of freedom is 8. We have just calculated. And this is a two-tailed test with alpha equals to 5%. When we see the interaction of these points, degree of freedom 8 and alpha 5%, the intersection point is the critical value of t, which is 2.306. For lower region, it will be minus 2.306, and for the upper region, it would be plus 2.306. So it is 2.306. We can also calculate the same value through Qt function in RStudio. We can look at the class of Qt. It is a function. And we can also see the documentation related to it. This is the documentation. You may read it. The syntax is I'm applying this Qt function. The p-value is 0.025 because mind it, my alpha is 5%. And because it's a two-tailed T distribution, both the sides, on the left side and the right side, alpha would be divided by 2. So it will be 2.5% in both the cases, left as well as right. So my left tail would be 2.5% and my right tail also would be 2.5%. My degree of freedom is 8. In the first syntax, I'm saying that my lower tail is true because I want to calculate for my lower tail. And here it is false, so that I can calculate both the lower region critical key values. So here are the results. For the lower region, the critical value is minus 2.30, and for the upper region is 2.30. So it's exactly the same which we have just calculated, which we have just seen. Next, we want to calculate margin of errors. Margin of errors means the distance from the point estimate to the upper and lower bound of the interval. Point estimate we discussed in the other video where we linked confidence interval and the dependent variable prediction. You may visit that video. The link is there on the I button above. So my margin of error is equal to critical t value which we have just calculated multiplied by standard error. This standard error we can take from the summary from the regression results. So after running it, for temperature, I can look at the standard error. It is 121.6. So using this value here, we can calculate margin of error. This 2.306 is my critical t value and 121.6 is my standard error. So when I multiply it, I get the margin of error. So it is the distance from the point estimate, and the point estimate is 1105.4. So now I can calculate my confidence interval, which is the point estimate plus minus margin of error. So it's a range of value where my point estimate most likely fall. So calculating it manually, the lower region of confidence interval would be the point estimate minus margin of error. So it results into 824.99. And when I look at the upper region of confidence interval, it would be at point estimate plus the margin of error. Calculating it, I get 1385.81. These are the confidence interval I've calculated manually. Now let's see how RStudio calculates it. So the command is very simple. We use the function confint. So we use the function confint and the results from my regression. And when I run it, I get the same intervals which I've just calculated, 824.8314. It is blocks the same. And 1385.878 blocks the same, which we have just calculated manually. So it's showing 2.5%, 97.5%. Because our alpha level is 5% and when alpha is divided by 2. So in both the sides, it will be distributed. So it will be 2.5% on both. So now suppose I want to look at the confidence interval of only my independent variable, not of the intercept. So I can mention that the parameter I want is temperature. When I run it, I see only temperature as my parameter here and not the intercept. By default, it shows the confidence interval at 95% confidence level. Now, suppose I want to change my confidence level to 90%. I need to add one more argument here that to take my confidence level as 90%. When I run it, I see at 90% confidence level. So this is 5% on both the sides. I can run for 99% confidence level. So here are the confidence interval at 99. I hope you have enjoyed the video. Thanks for watching.